Children, today we are going to discuss about P block elements assignment 4. So in assignment 4, your objective bits from 18th group elements, that is called noble gases. So in the first question, the most abundant noble gas is, you are given options, Z is equal to 2, Z is equal to 10, Z is equal to 18 and Z is equal to 36. These are given the options children. So now you can observe here, Z is equal to means this is becomes so helium, this is about to neon, this is about to argon, this is about krypton. So now which is the most abundant noble gas children? In air especially, that is about argon. So that is why your atomic number how much can choose? 18. So option C is correct children. Next question children. In period, which group elements possess highest ionization enthalpy? Which period? Asking here, in a period, which group elements? And in a period means it can take any period. Any period? Which group elements? You know, left to right ionization potentials are increases in periods. That means which is the last group of the elements in the periodic table? That is zero group elements. That is why here options in periods, which group elements possess highest ionization enthalpy? Always, every period, the last group of the elements exhibits the highest ionization enthalpy. For example, in first period, only two elements are there, hydrogen and helium. So, which is highest ionization enthalpy? Helium. Like second period, starts from lithium, ends with neon. Which is highest ionization enthalpy? Neon. So, like that. In third period, starts with sodium, ends with argon. Which is highest ionization enthalpy? Argon. So, in every period, left to right ionization enthalpy values are increases. So that is why in every period the last group of the 18th group elements are highest ionization enthalpy. So that is why in the given options which group elements here? 18th group children. So that is why your option B is correct children. So enter the periodic table also which is highest ionization enthalpy? 18th group of the first elements, because in the group again ionization enthalpy values are decreases. That's why in 18th group the first element is helium. That is why in the periodic table highest ionization enthalpy of the element is helium. Lowest enthalpy of the element is ionization enthalpy of the element is cesium. But francium also, but francium is a radioactive element. It is not considered as a property comparison. That's why the least is about cesium. Next one. Which of the following periodic property is decreased from top to bottom in 18th group? Here given properties, one is about delta H of Eg. Eg means electron gain enthalpy. One more is given here, delta H of I, that is ionization enthalpy. One more is given children here, density. One more is given children here, boiling point. In these properties, which properties are decreased from top to bottom in 18th group? So, top to bottom which are decreases here? This is electron gain enthalpy, decreases. Ionization enthalpy values also decreases. But here, density not decreases because atomic mass increases, density also increases. Boiling points not decreases, boiling points also increases because increasing the van der Waals force of attractions. So that's why these two are increases, but these two only decrease. That's why here 1 and 2 are decreases. In the given options, which is correct children? D option is correct. In D option, here 1 and 2, these two properties only down the group decrease. Eg means electron gain enthalpy. I means ionization enthalpy. Okay children. Next question children. Question number 4. which of the following statement is incorrect? Here given the statements, all noble gases are monatomic. You know, the representation of the formula, monatomic only. Helium symbol He, neon symbol Ne, argon symbol Ar, krypton symbol Kr, xenon symbol Xe, radon symbol Rn only, but not He2, Ne2 like that. That's why these are all are monatomic gases. Second statement, noble gases are colorless, odorless, tasteless. That is also correct. Noble gases are less soluble in water. No, noble gases are highly soluble in water. That is the wrong statement. One more statement, noble gases have very low melting and boiling points. Not low melting and boiling points. These are also high boiling points. So that is why here which is the incorrect statement? Noble gases are less soluble in water. That is here C. That is incorrect statement, children. So that is fourth one. Next goes to fifth one. So what is the fifth one, person? In fifth one, noble gases have very low boiling points because. So the noble gases are low boiling points because what is the reason? Here presence of dispersion forces or van der Waals forces. So the van der Waals forces are again dipole forces, here ion dipole forces, here dispersion forces also. That's why noble gases are exhibits here. London dispersion forces. It is the weakest forces. That is why these are low boiling points, children. And also monatomic gases. So that is the here given options. Here fifth one is A answer is correct, children. Next, children. Sixth one. All noble gases occurs in the atmosphere except one. What is that? Except one, tell me, children. Except one, that is radon. Because of radon is a radioactive substance. It does not occur in the atmospheric air. It is occurs in the disintegration or decay of radium. Decay of radium to form radon. Along with one more noble gas also formed, that is called helium. Whenever radium decomposes or decay to produces two noble gases. One is called radon, one more is called helium. Helium is nothing but alpha particle. Whereas your radium, radioactive substance, your decay of alpha particle, then to formation of new radioactive substance is radon along with helium. So that is why radon is not present in the air. So that is why your option can choose as sixth one B. Next one, children. Which of the following noble gases has the highest positive electron gain enthalpy? So here one of the important points, children. In generally, electron gain enthalpy values are negative because of exothermic process. But whereas here zero group elements, all electron gain enthalpy values are positive only. Why? Because here already stable electronic configuration. Completely filled electronic configuration. That's why noble gas of all are here. First electron gain enthalpy values are positive values only. Even though these values in the down star group in generally decreases, but in P block every group second element is more electron gain enthalpy than first element. So that is why we are asking which one noble gas is highest positive electron gain enthalpy. That is why in noble gases, highest electron gain enthalpy of the positive is second element. Which is the second element? Neon. That is why here neon is the correct answer. That's why, children, here answer is D. That is highest positive electron gain enthalpy of the noble gas is neon, children. Next, children. Question number 8. Which one has the highest boiling points? Which one has the highest boiling point? Already discussed. What happens here? Boiling point property? Down the group increases. That means in the noble gases, the last element of radon is highest boiling point. But we are given options of krypton, xenon, helium and neon. As for options, here Next to radon, which is element highest to boiling point? Xenon only. That is why we are given options. Xenon is the highest boiling point. That is why here 8th one is children. Which answer? B is the correct answer. Next children. Question number 9. Consider the following statements about helium. You are given statements observed. What is the first statement? Helium possesses low positive electron gain enthalpy. Low positive electron gain enthalpy. Lowest positive electron gain enthalpy due to small size among the group of 8 elements. Next, helium has lowest boiling point around 4.2 kelvins. Helium has unusual property of diffusing through rubber, glass, or plastic. Helium has no octet structure. So now you are asking, consider the following statements about helium. Which statements are correct? So you know, helium possesses lowest positive electron gain enthalpy. Lowest positive electron gain enthalpy as compared to neon. So that's why, due to what is the reason? Small size, that is correct. Helium has lowest boiling point, that is 4.2 kelvins. That is also correct. Next, due to diffusion property of helium, so it is diffusing through rubber, glass, plastic. That is also correct. Helium has no octet structure. Because of helium, only doublet only, outer shell only 2 electrons. That's why all are correct statements only, children. That is why, as for options, here 9th one can choose A option. All are correct statements only. Next children, question number 10. True compound are formed by. So the true compounds, here the noble gases, the first 2 elements of helium and neon does not form any true compounds. Why? Because helium, neons are too small size, absence of d orbital, high ionization and tau. Due to these 3 reasons, not possible to formation of true compounds. Whereas the last elements are there, argon, krypton, xenon and radon. So these elements are forms of compounds, especially the last 3 elements of krypton, xenon, radon compounds are true compounds, can be identified. But argon also, formation of the compounds are unstable. But very true compounds are here, krypton, xenon, radon. But even though radon compounds are radioactive substances, but majorly are krypton, xenon. So now we are given as per options, krypton, xenon, radon. Here option A is correct, children. So these are familiar to formation of here true compounds. Next children. Question number 11. Xenon combines with which of the following elements? Here xenon generally combines with the high electronegative elements. In the periodic table, which are high electronegative elements? Fluorine and oxygen. So that is why here, as per options, both are there, fluorine and oxygen. That's why both options is present is option D is correct, children. So that's why 11 can choose D option. Next, here given one match the following, children. Here as per reactions, observe here, one of the reactions is given Xe plus 2F2. The ratio is 1:5 ratio. At what temperature? 873 Kelvin's temperature, 7 bar pressure. So the ratio is how much? 1:5 ratio. 1:5 ratio means here combining of xenon and fluorine mixtures. Here one, which compound is given here? Formation of here XeF4. How many fluorines are there? 2 fluorines, 2 molecules, 4 fluorines. Which compound is formed? XeF4 is formed. But XeF4 is which shape, children, here? XeF4 is the shape is here F and F, and also contains here lone pair of electrons. Here also contains, children, one more lone pair of electrons. So this is the shape of the molecule, but it undergoes hybridization is sp3d2. So It is the shape is square planar shape. What is the shape? Square planar. So, here 1:5 ratio of xenon and fluorines are combined at 873 Kelvin, 7 bars formation of the compound XeF4, and the shape of here is square planar. So, XeF4 square planar product is formed. So, here as for maths of foreigns, so you are asking first one is XeF4 and square planar. One more is given Xe plus F2. They are using fluorine is excess of fluorine. Here the maintained temperature is 673 Kelvin temperature. So now here which is the possible children here? Here as per ratio, here the formation of XeF2. What is that? Second one is XeF2. For XeF2 what is the shape children here? XeF2 is a linear shape. Fluorine, here fluorine. Here remaining 3 lone pair of electrons. So this is the shape is linear, but it undergoes hybridization, sp3d hybridization. So Xe and fluorine combines to form xenon difluoride hybridization sp3d. The shape is linear shape. Next children, one more is given Xe plus fluorine. You can take it as 3 moles. If the temperature is 573 Kelvin temperature and 70 bars pressure. What is the positive product? XeF6. Here what is the shape here? Distorted octahedral. Distorted octahedral. What is the hybridization? sp3d3. So this is the information for children. Xenon and fluorines mixed up. Here the ratios are 1:5. Here about 1:2. Ratio is about here given 1:20 ratio. It is about 1:3 ratio. Even though it is also excess. It is also excess. It is also excess. Ratio are 1:3, 1:5, 1:20 at various temperatures and pressures formation of the compounds. So these compounds are shapes are here. XeF4 is square planar, XeF2 is linear, XeF6 is distorted octahedral. Here hybridations are here sp3d2, sp3d, sp3d3. Here in maths the following you observe here. So as for options, the correct answer is A option is correct children. Next 13. Here xenon fluorides are. Xenon fluoride means either XeF2, XeF4, XeF6 are. Here what about here? Colorless, sublimating substances, fluorinating agents, readily hydrolyzed even by traces of water. All of the above correct. Here some are here sublimized nature, some are here fluorinating agents, especially XeF2, and also undergoes hydrolysis. That is why all of the above are correct. That is why you choose the option children, D option. Next children, hydrolysis of XeF2 and XeF4 done separately. The common product is not. Which is not common product here? So, you are given options Xe, O3, HF and O. Your hydrolysis of XeF2 as well as hydrolysis of XeF4. XeF2 and XeF4 undergoes hydrolysis. So your XeF2 undergoes hydrolysis. Here the formation of the product is here HF and XeO3 and O2. Here also XeO3 HF plus O2, which is not here common product here. Xenon is not a common product. So that is why here option A correct children. 14 these are A correct. Next children. Question number 15. Which one of the following reactions xenon compounds is not feasible? not feasible. You are given options. One is XeO3 plus 6HF. Second one is given XeF4 plus H2O. XeF2 plus H2O. This is 3 moles. Here 6 moles. This is 2 moles. 2 moles. One more is given XeF6 plus RBF. So now this is about A, this is B, this is C and D, which is not feasible. So the first one is not feasible, children. But whereas XeF4 undergoes hydrolysis, gives the products are here. Xe formation plus XeO3 formation and HF formation plus O2 formation. Whereas XeF undergoes hydrolysis, the product is Xe plus HF plus O2. So children here, in the before bit also, XeF2 undergoes hydrolysis, XeF4 also undergoes hydrolysis. So we are common is XeO3 is there. So here given in question number 14, children, once observed here, XeF4 undergoes hydrolysis. What the product is possible here? XeF4 undergoes hydrolysis. Xe is also possible. It is also possible for Xe. But XeF2 undergoes hydrolysis here. Again, HF, O2 and Xe. So now which is not common, children here? XeO3 is not there, children here. Only a HF, O2 plus Xe is formed. This is not common. So that is why in the 14th question, children, you have choose the option is B option, children. Not A. 14th can take as here B option. But in this 15th question, you are not feasible reaction, so this one is not feasible, children. This is not feasible reaction. So this is also possible here, children. RBF gives rise to what happened here? RB, XeF7 formation, complex formation. So generally you are using the formula MF. M is first group elements: sodium, potassium, rubidium, like cesium, formation of the complexes. What is the time? Here 15, which is answer? Option. Next, children. 16. Among XeO3, XeO4 and XeF6 of the molecules have same number of lone pairs on xenon. What are given? XeO3, XeO4, XeF6. Yeah. XeO3 which contains 2 lone pair of electrons. XeO4 which contains XeO4 no lone pair of electrons. XeF6 having 1 lone pair of electron. XeO3 also 1 lone pair of electrons. So that is why XeO3 and XeF6 both are having 1 lone pair of electrons. But XeO4 having no lone pair of electrons because of a xenon atom surrounded by 4 oxygens by tetrahedrally. So how many bonds are formed here? Total 8 bonds are formed. 4 sigma, 4 pi. Xenon atom outer shell, how many electrons are available? 8 electrons are available. That's why all our electrons participate in the bond formation. 4 are sigma bond, 4 are pi bonds. That's why in this compound no lone pair of electrons. But XeO3 6 bonds having 1 lone pair. XeF6 also 6 bonds 1 lone pair. So that is why they both are having same number of lone pairs. That is option B is correct, children. Option B is correct, children. Next, children. Question number 17. See question number 17 children. Here match the following. Here match the following is column 1, column 2. Here given column 1, column 2. Compounds are given. This is a 17%. HCF2. B is given HCO3. C is given HCOF4. And D is given HCF4. Now here column 2. Comparisons of here 1, 2, 3, 4. What about here? sp3, D3. This is a distorted octahedral. Second one is a sp3, D2, square planar. And this one is a sp3, pyramidal. Next we are given sp3, D2 with again square pyramidal. This is square pyramidal. This is square planar. And now we have observed children here, which is the correct option HCF2. What is the hybridization HCF2? HCF2 is linear shape, but sp3 dehybridization. Anyone is there here? It's not there. So then choose this one, sp3d, and write about here linear. So this is sp3d linear. HCO3, sp3 pyramidal shape. Next, HCOF4. HCOF4 is here 4 plus 2 6. This is about this one, square pyramidal. But here HCF4 is sp3d2 square planar. So okay children, HCF2 sp3 hybridization linear. HCO3 sp3 hybridization pyramidal shape. It is similar to ammonia molecule. HCOF4 is sp3d2 square pyramidal shape. HCF4 is sp3d2 square planar shape. Next children, HCF4. So now in these options, which is correct here? 17. Option A is correct children. Here HCF4 plus O2F2 gives rise to A plus O2. Again here A reacts with 3H2O gives rise to B plus 6HR. 6HR means should be required HCF6 children. So that is 6HR. Remaining here, what is the compound here possible? This is HCO3. So now, which compound here? A is this is A. It is also product is here HCF6A compound. So now you observe your balancing equation here. 4 chlorines, here 2 chlorines, total 6 chlorines. O2 is byproduct. Again here HCF6 undergoes 3 moles of water, product is HCO3 plus 6H is formed. So now that is why here A is equal to HCF6, B is equal to HCO3. A and B respectively. So that is why your option A is correct children. Next 19 children. Again here given HCF2 plus P5 gives rise to A, like HCF4 plus SD5 gives rise to B. Third one, HCF6 plus KR gives rise to C. What are your A, B, C children? See here, first one is about P5 means here product is HCF. This is plus P6 minus. Like that. It is also HCF3. XE F3 plus SB F6 minus. Next this is a K plus XE F7 minus. So these are the possible products children. A, B, C was it. So now as per options, you choose B option is the correct answer children. So next here, question number 20 children, I'll write here, question number 20. Question number 20. Here also, incorrectly matched. Again, here given all the compounds, XeF2, XeF4, XeF xenon chlorides, xenon oxides, all of them. Here, XeF2 is a sp3d linear shape. XeF4 is a XeF4. What is the shape? Square planar shape. Hybridization sp3d2. But here given sp3 and tetrahedral. That is incorrect match. But XeF6 sp3d3 distorted octahedral. XeO3 is again sp3 hybridization, that is pyramidal shape. But it here given sp2 and triangular planar. That is also wrong. Next to XeO4 sp3d2 square pyramidal. Xe2OF2, O2F2, here sp3d and C short shape, correct. Only here second and fourth are wrong. That is why your question number 20, your option is B only children. These are incorrect statements. Okay. So this is about the assignment 4 object of its discussion children. We are now discussing about 20 questions. This is about the especially in P block of the 18th group elements. Now in the overall chapter, we are discussing about in the P block, here various assignments, assignment 1, 2, 3, 4. So that is like 15th group, 16th group, 17th group and 18th group. Also sent to homework assignments also. You should practice the object of its from P block elements. Thank you children.